Dear participants, welcome to 5th International Congress on Human-Computer Interaction Optimization and Robotic Applications. The symposium is organized by Tokat Gazi Osman Pasha University from Turkey and National Technical University Kharkiv Polytechnic Institute from Ukraine. The symposium is also technically sponsored by IEEE Turkey section. Thank you for your scientific contribution and support to the symposium. Now, if you want, let's start the session. First paper belongs to dear Ivan Ralev. Dear Ivan Ralev, are you ready to present?
Yes, I'm ready.
Okay, you can start your presentation if you want.
Dear Professor, colleagues and guests, my name is Ivan Ralev. I'm a PhD student at the University of Russia. Today
Please, you have 10 minutes, okay?
Okay. I'm a PhD student at the University of Russia. Today I'm going to present our paper co-authoring with Professor Georgi Krstev. The following topic is analysis of the result of using gesture recognition in software application. The paper presents an analysis of the obtained result of control and interaction by means of a gesture of different software. 4 different software applications have been developed for this purpose using a specialized web camera. The user performed the gesture using their hand, a specific stick, a printed gesture, or using a black glove. The data were processed using specialized software for working with statistical data. The importance of external factors on the final result is determined. First application is a short quiz type game where a question with 3 possible answers is asked and the player must mark which one is correct by using a specific gesture to indicate it. The investigated gestures are turned up, turned down, and spread fingers. The conditions under which the user performs tests above the application are as follows: execution of the gesture with the left or right hand, different distance from which the gesture is performed, difference in the lighting of the room, the user is wearing different clothing during the execution on the gesture. The user wears various accessories to their clothing. This slide presents the results obtained when only one condition is used as an influence factor, for example, lighting. Due to the large volume of data, graphs are not present when there is a combination of several factors. From the graph, it can be seen that distance is the factor with the strong influence on the result. Next application was created to control another software like media player, photo viewer, and maps. After its design, development, implementation, tests were summarized under the following conditions. Different temperature in the room, the users wear different clothing, different backgrounds in the room, different lighting in the room, different hand used when performing the gesture, different distance between camera and player. This slide summarizes the influence of each of the studied conditions, how it affects each of the performed gesture. A good result is considered when all colored bars tend to 5. Fist, spread fingers, swipe right and swipe left visibly stand out from the others as it gets closer to the desired result. Buff, swipe up, and thumb up have lower overall performance. This slide shows a breakdown of the states in which a certain gesture is performed and what it impacts on the outcome determining success. 2 pie charts describe the data obtained under different influence of the state during the execution of a specific gesture. For example, the beginning shows what they are at the runtime when the user is not using a watch accessory. And we see uniformly in the to charts which is sign that this factor does not affect the overall performance, while there is a serious discrepancy in the last chart for temperature of 10 degrees Celsius and 18 degrees Celsius. This figure summarizes the effects of the different states of importance on the gesture by visualizing. The ideal case is to get a straight line located at the top. Such values are obtained with factors 18 degrees Celsius and single color background, while with a multicolored background 10 degrees Celsius and the distance of 1.5 meters, a serious curve is obtained, the point of which lie in some case well below a 5 rating. This slide represents the same data, and we can see the straight line in 4 and 8. The purpose of the developed application is to test the capabilities of OpenCV library as a means of facilitating the program to control software using computer vision. Black graph and a stick were used as means of control. The user works with the application under various external factors such as distance, clothing, background, and lighting in the room. In this figure, the obtained result of the performance test can be seen visualized in the form of a bar chart. On initial analysis, it can be noted that most of the data from the control tools used in the same with different observed when using different clothing. The uniformity of the data can be explained by the fact that the stick and graph perceived processed as the area of the frame containing the largest number of black pixels. Differences are seen when changing clothing when a short-sleeved shirt and gloves are used. This figure presents a summary dependency of the individual state against the overall result obtained. First figure depicts the dependency of the result against the distance, and in clarity stands out of the distance of a half meter from the camera to the stick or glass, in most vulnerable to achieve a good result. In second figure, it can be seen the most identical result obtained dependency on the clothing used, showing what this is not a determined factor. The maximum score is 3, which is due to the fact in some cases the areas of interest cannot be correctly identified, especially if black or dark colored clothing is low. With the background, there is a slight advantage in the result when the background is homogeneous, which can be observed from third figure. The lighting in the room is important for the correct detection and processing because if it is low, part of the frame are merged or recognized as black, resulting in the wrong areas of sequencing being marked. This can be seen from the last figure where the final results are nearly 1 unit higher when the room is lit. Tests were performed on the developed gesture recognition application using a standard web camera and a capabilities of OpenCV library. The condition under which the test are summarized as the following: different input device, different distance to the camera, lighting in the room, different background. This figure visualizes the obtained data from the performed gesture recognition experiments. A different combination of states in which the gesture is performed are considered. It is clear from the bar graph that recognition using a printed gesture is much more successfully than when using a black graph. This figure depicts the result data divided into separate charts. From the data, it can be concluded that the distance of a half meter to the camera when using a printed site, a result close to the maximum is obtained. And only when the room is darkened and the background is homogeneous, the result is 4. When using a black glass, a strong influence of the lighting of the room is noticed. The reason being part of the hand and the background are perceived as part of area of interest in which the corresponding gesture is solved. After analyzing data obtained during the test, it was found that various environment factors influence the successful recognition of a gesture to be used as a means of controlling software writing by a programmer. The distance to the camera and lighting in the room, the background, the temperature can be determined as the most significant. The crossing and accessory worn by the user are not essential. Certain gestures are more dependent on the mentioned conditions than others, so the programmer should carefully select the one they will use depending on where they are supposed to work most often. Thank you for your attention.
Thanks for your presentation. Dear participant, do you have any question about this paper? Okay, no question. Thank you again. I wish you success in your career.
Thank you.
Dear Nikolai Valov.
Colleague Nikolai Valov has to travel and cannot participate.
Okay, okay.
I will read his presentation.
You can
Okay.
present the study.
Okay. Present C.
Okay.
Okay.
You can start if you want. Please, you have 10 minutes.
Okay. Project-based teaching of students with development of a smart control of the free-range chicken house. Project-based teaching, PBT, organizes the learning process around project development and learning activities based on real practical tasks that present challenge for students to solve. Under classical teaching approach, students are usually passive and they're expected to memorize the information presented by the teachers. In the field of engineering education, it is important for the student to meet and solve real practical problems. According to the description of the project that they receive, it is necessary to develop a system for monitoring the parameters of the environment and controlling the door of a free-range room for chickens. The proposed smart system should be built from the following hardware modules: microcontroller, sensor for temperatures, relative humidity, illumination, and electric step motor, controller for charging the battery and controlling the step motor, lithium-ion battery, relay module. In addition, it is necessary to develop one software module with the following basic functionalities: automatic recognition of the onset of day, night, and respective opening and closing of the door, protection against accidental activation of the system by flashes car lights. The speed of movement of the door should be consistent with the sound of the birds. To be provided the system with the photovoltaic power supply. The system power supply to be buffered by a battery in the event of a mine's fire or lack of lighting when powered by photovoltaic. Possible of manual and automatic control of the system. The development software module should be web-based, which will be an additional convenience and allows an union with the appropriate access rate to be able to remotely monitor the parameters. relative humidity, illumination, ammonia level in the room, and measure door opening, etc. System architecture in general view. Vemos many microcontrollers. System operation algorithm. Creating smart solution system with ready-made platforms use a quick and convenient way to test students' ideas. The choose platform provides practically all the necessary controls and the component for designing user interface in mobile and browser version. It is fast, easy, and intuitive to work with the platform itself. A disadvantage of such a solution is that the data that is collected in the process of system operation is not stored with the developer, but somewhere on the internet in the whole code of the platform developer. This limits the use of this data for more serious analysis and the prediction of, for example, some events. For the purpose of the teaching, students implement switch system trope of the shelf platform is useful because they can quickly and easily be shown the entire process of designing and implementing a working solution in various Internet of the Things domains. It may even provide them to try to implement such mini monitoring and management project themselves. Thank you for attention.
Thank you for your presentation. Dear participant, do you have any question about this presentation? Okay, thank you again. No questions.
Thank you.
Next paper belong to dear Wan Lee. Dear Wan Lee. Okay. Dear Rüya Zeki Kamal Baba. Dear Theodore Kalushko.
Yes, I'm here.
Okay. If you are ready, you can start your presentation.
Okay, thank you. Can you see the screen?
Yes.
Okay. Dear colleagues.
You have 10 minutes, please.
Okay, thank you. Dear colleagues, my name is Theodor Kalushkov and I am from Cyril and St. Methodius University of Veliko Tarnovo, Bulgaria. And I'm going to present you the report titled Models for Implementation of Augmented and Virtual Reality Technologies in Folklore Dancing Halls. The report presents the result of scientific study on how to increase the effectiveness of folklore dance training and preserve and popularize the Bulgarian folklore heritage using modern digital technologies. On one hand, a comparative analysis of the equipment for creating virtual learning materials is made, and on the other, the installation for the execution of already created virtual fragments is depicted with a higher priority. There are considered two models and they are estimated according to the dimensions of average density halls in Bulgaria. Unlike the other similar studies, this article does not focus on self-learning dance, but on teacher-assisted practice in a group format, which has been identified as more suitable for this art. The aim of this report is to present a deep analysis of the extent to which the existing technologies for AR and VR could be implemented in the educational process in Bulgarian folklore studying, in particular for Bulgarian folklore dancing, in such a way that participators, dancers, choreographers, and all interested, easily to transform and adapt the modern digital teaching or training with less efforts in investment. Currently, lectures, seminars, and lessons in the folklore dancing course are prepared through the power of verbal descriptive approach. And in addition, these resources are accompanied by illustrative material and where is possible with real demonstration. In this case, the three-dimensional visualization of the research object interactivity with it is missing and the learner is still in reality. In other words, immersion in the world of the studied object is needed. The beginning of the report contains research on prior developments and good initiatives on the topic. This part is very important because it outcomes an overview to which extent the virtual and augmented reality is used for better presentation and visualization in different areas of Bulgarian folklore. In this section is presented a selection of some prior developments to which the authors had access and the opportunity for more deep research. This section had been defined according to the criteria closest to the present research problem. Here you can observe the other part of the explored sources. The hardware models of dancing halls include all the equipment that is needed to create, edit, and represent AR and VR resources to the learners. For developing correct models, average dancing hall dimensions and their inside conditions are considered in this report. For ensuring accuracy of the models, the hardware for creating virtual content are separated from the hardware for editing, rendering, and playback. In this section of the report, some hardware models for creation of virtual content are discussed, such as the shown on these slide models. The model presented on the left picture contains a dual-lens stereoscopic parallax cameras. It is possible choice for filming the dance and implementing it into the 3D environment. It is a solution that does not require additional complex knowledge from the users. The main advantage is that the volumetric perception is achieved only from a precisely defined angle, and virtual objects cannot be viewed from all sides. This can be partially overcome by installing several cameras at different points in the room to capture the dance, as it is shown on the left figure. Then the observer can play different films manually or switch between the different viewpoints from the deployed cameras. An advantage of this model derives from the fact that 3D film materials can be played also directly on an autostereoscopic displays, although these devices have so far failed to establish themselves in the market. The second model shown on the right figure shows filming a folklore dance with only one Insta360x3 camera in the middle of the dancing hall. It implements a camera or cameras assembled from 180 viewing opposite directions camera modules stitched back to back. In this case, each matrix records a hemispherical image, and the two hemispheres are merged into one sphere by a specific application software before being reproduced. The mount or stick on which the camera is placed is also deleted by the software. The films created with such cameras can be of high resolution with high number of frames per second and are played both on ordinary monitors and TVs and also on VR boxes. The possibilities for playing virtual content are significantly more than those for creating it. On this slide are shown technologies that are discussed in the report, their advantages and disadvantages for application in teaching Bulgarian folklore dancing in real dancing hall environment. The table on this slide summarizes the outcomes of all discussed above technologies and their applicability for the needs of the folklore dancing training process. On the basis of the presented above prior implementations and the detailed analysis of the existing VR and AR technologies and their applicability in the process of Bulgarian training folklore dancing, two models are developed. They are valuable because they can be used by the Bulgarian folklore specialists to ensure more attractive and innovative way of presenting the specifics, the variety and the beauty of Bulgarian folklore heritage. During the development of the proposed modules, many factors specific to the teaching of Bulgarian folklore were taken into account. The material base, the presence of group activities in most cases, the need the folklore specialists to work with new and sometimes unfamiliar technologies, the size of the hardware configuration, which sometimes could be a problem concerning the normal work in the hall, and etc. First model contains stereoscopic cameras for creation of virtual content and mixed reality glasses for the dancing students. This model is positioned closer to the future and is more comfortable for the users, but uses more sophisticated software and hardware. The second model is a combination of 360 cameras and VR boxes. It is more acceptable and easy for implementation. In addition, it requires less knowledge from the person responsible for content creation, for example, dance instructor. As a conclusion, I may say that the implementation of AR and VR technologies as an educational tool is far from a new concept. The technologies needed for development and access to interactive content are also becoming easier to use and more affordable. In the Bulgarian educational system, there are good examples and initiatives in this direction, but the realization of in great extent of the potential of these modern technologies in the educational process has not been made yet. Studying Bulgarian folklore, especially when it is directed to young people, is very suitable for integration of these modern technologies for realizing effective and attractive delivering of new learning content and immersion in virtual spaces. The future work aims to investigate the advanced possibilities of virtual and augmented reality technologies for an attractive presentation and promotion of the Bulgarian folklore heritage through developing various applications shown on this slide. So I want to thank you for the attention, and I'm ready to answer if you have any questions.
Thank you for your presentation. Dear participant, do you have any question about the presentation? Okay, no questions. Thank you again. I wish you success, dear Theodore Kalishko.
Thank you.
The next paper belong to dear Alhaji Osman Ba.
Yes, yes, I'm here.
Okay, if you are ready, you can start your presentation.
Okay,
You have 10 minutes, please.
okay. Can you see the screen?
Yes.
Okay, my name is Alhaji Osman Ba, PhD student at Chokrova University, Department of Electrical and Electronics Engineering. Our research topic is classification of attempted hand movements from EEG signals using the Hardeman basis matching movement-related cortical potentials. Okay. My co-author is Associate Professor Sami Arija. So this is the content. We have like it. As you can see from the screen, the goal of the study, introduction, EEG waves, BCI framework, data set, proposed approach, findings and discussion, then conclusion. The goal of the study is to extract features from the movement-related cortical potentials resulted from the attempted hand movement activities, utilizing the delta band by Hardeman basis, and which can be suitable for online and real-time BCI applications. Introduction. BCI, or brain-computer interface, is a technology that helps to establish a communication between the human brain and other devices. These signals, or brain signals, have been used in various BCI systems, utilizing P300, Evo potentials, MI, and AM. It means like motor imaging, and also attempted movement. We use this technology, EEG, to extract, or technique, to extract brain signals because it's non-invasive and it's really cheap and easy to implement. We have like 5 waves, EEG waves. As you can see from the screen, we have the delta waves, delta, alpha, beta, and gamma, and their frequencies. There's the behavioral traits, and this is the waveforms, as you can see here. So in our studies, we use the delta wave because it's so slow, and from the data sets we have. This is the BCI framework. As you can see here, we have stages. We have the signal acquisition, pre-processing, feature extraction, classification, signal output, BCI application, and the feedback. This is the framework of a BCI from the brain to the feedback. The dataset we used, got it from BNCI Horizon 2020 by Patrick Offner et al. 2019. This dataset recorded 10 male right-handed subjects with spinal cord injury from age 20 to 69 years. And they performed 5 types of categories. First, we have the pronation, supination, palmar grabs, lateral grabs, and hand open, as you can see from the screen here. So we continue with the data set. From the trial stage of the data set, a cross and a beep sound appeared on the monitor computer screen. The subject were asked to attempt the 5 motor imaginary tasks. When the class cue appeared on the monitor, the presentation of a target cross cue was intermittent by a random length, as you can see from the sketch diagram here. From this fixation class cue, the movement happened between 0 seconds to 3 seconds, and the whole process took 5 seconds. Our approach, we propose a novel Hardeman based feature extraction method for classifications of EEG signals recorded from the person with spinal cord injury. The feature extracted projections on selected Hardeman transform. We use 4 channels, C3, C4, and F3, F4, because C3, C4 it's for motoring, because most previous studies have already done that. Like most of the motor area is from the C3 and C4 channels. And we use the frontal part of the brain, which is F3 and F4. We use these 4 channels to extract features in order to classify these 5 classes. We use 2 classifiers, the linear discriminant analysis and multi-class models for support vector machines. This is the proposed approach, like the flow chart of the proposed method. First, we have the EEG data we got from online, and we divide the EEG data or the signals into trials and tests. We extract MRCP, which is movement-related cortical potentials of the 4 channels I mentioned earlier. We filter these MRCPs with Savinsky-Colli algorithm. It's a MATLAB, it's in MATLAB function. And we extract features based on Harman transform by projecting MRCP of channels related to each category. Next, these features, we created a vector for test and train. Then we classify these features using the FDA and MSVM, as mentioned earlier. The proposed approach still continue from the Savinsky-Colli algorithm. We smoothen the MRCP because brain signal has a lot of noise. So we use this to clean the signal. As you can see here, we have channel C3. We just take channels C3 of the 5 classes. We have noisy signal here. We filter it using this algorithm from subject 5. So the proposed 1 second, in our study, we use 1 second, as you can see, from 0.5 to 1.5. We use 1 second epoch length in order to get an actual epoch. Okay, from the C3, C4, F3, F4 channels. So the purpose of 1 second epoch consisted of 256 samples. Therefore, matrix size of the transform was 256 by 256. The Harman basis were selected by projecting MRCP of the channels related to C3, C4, F3, and F4. So these Harman bases were selected by projecting MRCP of channels related to each as follows. We got this, as you can see from the equation here, where M is holding the MRCP from the 4 selected channels and generated by each category in each column, and H is the Harman matrix. Then we took the 8 highest coefficients in magnitude were chosen, as you can see here. Bases providing the highest 8 coefficients in magnitude were chosen from the Harman basis. Okay, finding and discussion. At the classification phase, the data was partitioned into training and test, where we used 67% of the data as training, which is 48 feature vectors per class. And also we have 33%, which is 24 feature vectors per group, was assigned for testing. A feature vector consists of 7. This 7 here, we use first 8, we extract 8, the highest magnitude 8. So the basis which correspond to 0 hertz was removed. That's why we have 7 here. So we projected this 7 to the 4 channels, which equivalent to 28 features or attributes. The training data was used to learn Harman basis representing MRCPs and classifiers parameters, while the test was used to validate the method. An average 30% accuracy above chance level of 20% was achieved with linear discriminant analysis classifier. So in our studies, we got 30% accuracy above chance level, which is 20%. So also we found out that the accuracy of the movement classification heavily depends on the integrity of the input data set. In other words, also it shows that some subjects conform to attendant movement tasks better than others. This shows that not everyone is the same. We human beings, we all have different brains. So it depends on the individuals. So for these studies, we extracted EEG from people with spinal cord injury, and also age difference also counts. As you can see from the table here, these are the 2 classifiers we used. the Fisher linear discriminant analysis, and the multi-class SVM. As you can see here, for subject 1, we have 22.5 for the first for the first classifier and 20.9 for the second classifier. When you compare this PO1 or subject 1 to subject 5, there's a great difference. We have 36.6 for subject 5 and 22.5 for subject 1. There's difference. This shows that we humans, we are different in brains also. So conclusion, in this study, we propose a feature extraction method in delta band of EEG signals to categorize attending hand movement, such as hand open, palmar grabs, lateral grabs, pronation, and supination. We employed a relatively easy method instead of using more sophisticated methods to classify motor EEG signals, and which is suitable for online real-time applications. Thank you all.
Thank you for your presentation. Dear Parsim, do you have any question about this paper?
Sorry, I had a question.
Okay, please.
In your study, how many channels did you use? Which device?
Okay, we use 4 channels, as I told you earlier. The original data had 64 channels.
64.
Yes, for us, we use 4 channels in order to reduce the
All right.
yes.
So how did you decide C3, C4, F3, F4?
Okay, from the data set has a description. So we took the C3, C4 because previous studies have already said that the C3, C4, it's meant for motor area of the brain, and F3, F4 is the frontal part of the brain. So we try to use this 4 and see if this relates to the movement related for the things that we are looking for.
I get it. But also, why did you choose the delta band?
We use the delta band because the previous studies from the data set we had, they use delta band also because it's like a slow signal. It's a slow, as you can see here, it's a slow waveform as compared to the others. And it's also like low frequency band from 0.3 to 4. So we decided to use this one. In our new approach, now we are trying to see if we can use the alpha or the beta band. So compare the 2 results. That's our future plan. Yes.
All right. I mean, attributes are too few and aren't the result too low?
Yes.
Because result is very, very low.
Yeah, it's low. Our aim was like to get higher chance level because the chance level is 20%. So we try to get higher chance level. So we are also trying to improve this by using other techniques.
Yes. I get this data set link, any publicly data set?
It's only one from the main author. So that's why we are trying to use this, because I'm sure if we use this technique to another data, which is more open, we might get higher accuracy as compared to this one. Because this data, I think it's only because I've checked a lot of literatures, a lot of papers. I haven't seen any publication from this data set. But you can find it from BNCI Horizon 2020. You can find the data there from 2019.
Okay, thanks.
Okay.
Thank you for your answer.
You're welcome. If you have any other question you want to ask, you can email me from my email. It's
Dear Parsim, do you have any question? Another question? Okay, no questions. Thank you again, dear Alhaji Osman Bak.
Thank you.
I wish you success in your career.
You're welcome. Thank you.
Dear Muhammad Al Uzai, Dear Muhammad El-Huzayi. Dear Taha El-Elvi. Dear Taha Elvi.
Dear, my name is Tamam because it's my turn.
Okay. You are ready, dear
Yes.
Tamam Al-Rawi?
Yes, I'm ready.
Okay. You can start your presentation.
Can you see my slides?
Yes.
Okay.
You have 10 minutes, please.
Okay, thank you. My name is Tamam Al-Rawi. Today I will present my topic in the title of dual band high efficiency fractal reactor for RF energy harvesting system. For the green energy, harvesting is the most important topic these days because it's a sufficient power, adequate lifetime, and easy low cost installation and flexibility. For RF and microwave energy is one of the external non-natural sources that can be captured and used as transmitted power wirelessly. Therefore, it's subject for research to develop a microstrip antenna to design a printed circuit to transmit electromagnetic energy wirelessly at the same time to be used for data transfer. This is a performance comparison between different published antennas. We can see the size and the frequency and substrate gain, substrate type and the gain. We can see the size is like between like 60 by 60 millimeter until like by 110 by 110. And for the frequency, we can see like it's the number between 0.915 until 3. And for the substrates, we can see it's a lot of types. It's like FR4, Teflon, and the other. And for the gain, it's between 3.1 dpi until 6 dpi. The reason or choosing fractal printed circuit geometry because the dielectric materials usually show a non-negligible amount of the losses. These losses are represented by the amount of the conserved energy in the structure radius of the dielectric material. And it may have a drawback on the efficiency of transmitted electromagnetic power. In such case, to reduce the amount of the conserved energy, the use of fractal printed circuit geometry is suggested to minimize the patch conductor area that minimize the dielectric losses effects. We can see for this geometry for the antenna design, this equation and this geometry. By this geometry, this patch geometry is going to increase the antenna bandwidth and also matching. The back patch of antenna is covered with a partial cover band, and we can see it by these equations. For the frequency resonance of the fractal geometry, we use this equation, and what is mean of n is the integer number of multi-frequency that is given by fractal, and epsilon r is the dielectric effective constant, c is the speed of light, d is the substrate thickness, and d is the ellipse measured diameter length, and p is the ellipse perimeter. For the antenna design, we use this design, it's like triangular, and we use this equation, and we know that W is the conductor trace width, and epsilon r is the dielectric constant of the substrate. Or why RF and microwave-based wireless power harvesting? Because it's to minimize the cost by limiting the hardware and battery size, and it's easy to use because there's no need for charging mats and no user action is required. For the problem statement of the proposal. First, the antenna type must choose to handle low power capacities such as a microstrip printed circuit antenna. Fractal patch antenna structure must show enhanced bandwidth response to receive most RF and microwave frequencies in the space. And the patch structure must choose a frequencies mode around the Wi-Fi bands to rectify the energy to DC current. For the requirements with RF and microwave energy harvesting, it's available. Input power to the rectifier is low. Non-linear dependence of the rectifier, high efficiency of AC to DC conversion, and rectifier should have minimum power loss to increase the overall efficiency. We can see here the microstrip antenna between the advantage and the limitation. For the advantage, it's like we have like lightweight, low volume, low profile, low fabrication cost, and we can see the others. For the limitation, it's like narrow bandwidth, not the greatest gain we can, incapable of handling high power, and other things. To overcome the antenna limitation, we use the advantage, like the fractal geometry shows excellent size reduction, and fractal antenna provide multi-bands at different frequencies resonance. Such structure may be a subject for providing ultra-wide band. The antenna gain of fractal geometry can reach excellent enhancement in comparison to traditional antenna. The proposed methodology and procedure. Using a multiply band patch antenna based on fractal geometry. Second, the antenna will be designed and simulated by using CST, MWS, and HFSS. Perform the related electronic circuit, including AC to DC converter. Fabricate the antenna structure and integrate it to the related electronic circuit, then test the performance. Measure the harvested power in real outdoor environments. We can see in this figure the architecture of RF energy harvesting system. You can see the antenna, the matching circuits, RF to DC conversion rectifier, DC to DC converter, charging circuits, and battery. For the requirements for antenna design, provide resonance around certain bands such as Wi-Fi, GSM, and other common applications. The antenna must provide an excellent matching over the frequency bands of interest. The antenna must provide an acceptable gain for the interbands of interest. And the antenna size must be miniaturized to serve the compacting process. The most important required parts, the matching circuit first, and the rectification can be obtained using Schottky diodes, voltage multiplier, and the bridge rectifier. We use a commercial rectifier block circuit diagram. We connect this antenna of our proposed study to measure the output voltage. For this diagram and figure, for this the antenna is fabricated according to the design that obtained CST and HFSS to provide a frequency at 2.45 GHz and 5.8 GHz with gain about 4.5 is the first node and 2.5 to the second node. We can see the radiation patterns and the output voltage in 2.45 GHz and 5.8 GHz. When we measure output voltage with respect to the value of the input power at 2.45 and 5.8, the variation is linear. That gives us indication of coupling between the antenna structure and commercial for RF harvester is well done. We can see the comparison between the measured and simulated for the harvesting efficiency at 2.45 GHz and 5.8 GHz. And we can see like the numbers is increased and it's well done. For the future outcomes of the energy harvesting and promising application, system integration and wireless charging of low power, the application of such system to the biomedical devices based wearable and implementable terminals. The ability of integrating such system to hybrid engines, the integration with satellite station, which is very important, adding such system to wireless sensor network nodes, And for the conclusion, for the purpose of RF harvesting and 2.45 gigahertz and 5.8 gigahertz frequency bands, the antenna is miniaturized to 30 by 50 millimeter using a fractal structure. The suggest antenna is determined to have return loss of 20 dB at 2.45 gigahertz and 17 dB at 5.8 gigahertz at 2.45 gigahertz and 5.8 gigahertz respectively. The antenna gain is found to be 4.5 dpi and 3.5 dBi respectively. The measurement and simulation findings are found to be in good agreement, and the antenna harvesting efficiency is found to be about 65% and 40% at 2.45 gigahertz and 5.8 gigahertz respectively. And you can see here the difference of my work. This is the last. Thank you for listening to me.
Thank you for your presentation.
You're
Dear
welcome.
person, do you have any question about the paper? Okay, no question. Thank you again. I wish you success.
Thank you. Welcome.
Dear Gabriel Canev.
Yep, can you hear me?
Okay. If you are ready, you can start your presentation.
One moment, please.
You have 10 minutes, please.
I have a bit of a problem with sharing my screen. Do you see my browser now?
Yes.
Okay. Hello, everybody. I'm Gabriel Canev, and today I'm going to talk about leveraging user experience for enhancing product design, a study for collecting data and evaluating it. So, user feedback refers to the valuable information, opinions, and reactions provided by individuals who have used a particular product or service. It's a vital source of insight for businesses and developers to understand how users perceive and interact with their offerings. User feedback can come in various forms, such as writing comments, ratings, surveys, reviews, suggestions, book reports, and even direct conversation. One of the primary purposes of user feedback is to gather users' thoughts and experience regarding the product or service. It allows users to express their satisfaction, frustration, preferences, and needs, providing valuable perspectives that might otherwise go unnoticed. Gathering feedback allows businesses to adopt a user-centric approach to design. By collecting feedback from users, experienced professionals gain insight into their needs, preferences, and pain points. This user-centric perspective ensures that the design process is driven by the actual experiences and requirements of the target audience. It helps in identifying and addressing usability issues. Here we can see the most popular methods of collecting UX information, which are NPC, which is Net Promoted Score, MAQ, which refers to the Malcodial Emotional Queuing System, the Attack Diff, and the UAQ. On the two photos, we can see on the bottom one, we can see the NPS, the Net Promoter Score, and on the right, we can see the MAQ2. So the most popular one, which most of you maybe have seen, is the Net Promoter Score, which is used mostly to score things from 0 to 10. It provides businesses with a simple way to access customer sentiment and gauge the likelihood of customer recommending the product. So if people get a score higher than 8 and up, they are going to give the product a shot and give an opinion to a person which may use the product at hand. The MeQ2 refers to the multi-role emotional queue system that primary goal is to enable computers and systems to better understand and respond to users' emotions. The attack diff includes only three qualities which are different from the prior two, which are programmatic quality, anodic quality, and attractiveness. The last one, which is a bit different from the prior three, uses these six main dimensions, which are attractiveness, the dimension relates to the visual design, aesthetic, and overall appearance of the product. Perspicuity, this dimension focuses on the clarity and understanding of the product. Effectiveness, this dimension reflects the perceived effectiveness of the product. It assesses users' perception of how quickly they can accomplish tasks and achieve their goal with the system. Dependability, stimulus, and novelty are the other two which are also important, but not important in this paper at hand. I'm sure that you have found other ways to gather feedback, which can be interviews with focus groups, user testing and observation, customer support and help desk iteration, online reviews and ratings, usage analytics and user behavior tracking, feedback suggestion forms, and methods based on the physical and psychological state of the user. Methods used to evaluate data collection about the UX. Overall satisfaction. User ratings often indicate satisfaction with a product or service. By examining the distribution of ratings, calculation averages, and comparing ratings across different user segments, we can gauge the general level of satisfaction among users. The information helps businesses access the overall success of their UX efforts and identify the areas they need to pay more attention. Identifying the pain points, user opinions, and feedbacks can uncover specific pain points or areas of dissatisfaction. Analyzing the frequency of and nature of users' complaints or negative opinions allow us to identify common uses that need to be addressed. By prioritizing and addressing their pain points, businesses can enhance the UX and mitigate users' frustration. User feedback importance. User ratings and opinions often provide insights into which features or aspects of a product or service are most valuable by users. Analyzing user opinions on specific feature or function helps in understanding user preferences and priorities. This information can guide product development, the UX design decision, encouraging that resources are allocated to enhancing the most important aspects of the user experience. And the last one, which is the methods used to enhance data collection about the UX, user behavior, and comparing and benchmarking. User ratings can also shed light to user behavior and usage patterns. By analyzing users' feedback in conjunction with other data sources, such as usage analytics, businesses can gain a deeper understanding of how users engage with prior products or services. This insight helps in optimizing user flow and identifying opportunity for upselling or cross-selling and tailoring the UX aligned with user feedback and experiences. Comparison and benchmarking. Users' behaviors, users' ratings and opinions can be used for benchmarking purposes, allowing businesses to compare their performance against industry standards or competitors. By analyzing ratings and opinions concerning competitors' offerings, businesses can identify areas where they excel or lack, leading to insight and strategic decision-making and comparative position. There are various ways to determine the user experience. The importance of satisfying the users in the area that have been widely researched. There's a continuous development of the new methods and the UX evaluations. The surveys are a relatively cheap and easy way to gather some knowledge about the user's thoughts, but it does come with some disadvantages, as they are developed in the wildness of the users to fill out the survey as well as their mood. Additionally, to be reused, the surveys have to be done periodically and relatively frequently in order to track the user's familiarity with the product. Those disadvantages are valid as well for many of the other metrics: interviews, observations, customer support, online views, and etc. Thank you for your attention, and I can answer questions if there are any.
Thank you for presentation. Dear participants, do you have any question about this study? Okay, no questions. Thank you again, dear Gabriel Canev.
Thank you.
Dear Adrian Pisla.
Hi, this is Süleyman Toraşan. I will be presenting our results.
Okay, no problem. If you are ready, you can start your presentation.
Yes, let me share my screen.
Okay.
So hello again. Thank you for having us in this conference. We are a group of researchers. I'm a PhD student at the Technical University in Cluj-Napoca, Romania, and university teacher at the German University, Göttingen-Geislingen, HFU. So we've done some research about the wisdom of age, focus on collaborative learning, which means human-computer interaction. This is our brief outline, so I will have a brief introduction, tell you a little bit about the context of the research, more about the philosophy of the research. Then it is a consortium of different universities and companies. Briefly, I will talk about that, then I will go over to the research, talk about the human-computer interaction, then the company's perspective, mentor's position of the analyze, a business perspective, and then lead to the conclusion. So cobots are are a good example of what is happening on the market. Cobots are a special type of robots, for those who don't know cobots, that can work next to a human being without being in a cage. They are safe, they have sensors, they are not so strong, they stop if they touch a human, so they don't hurt the human. It might hurt a little bit if it's on a body part that is maybe not so strong, but overall, they can work next to a human, to keep it brief. So, but it's not so easy as described, just bringing a cobot and implementing it. It is a bit more complicated, of course. You need some engineering skills, you need some programming skills, you need to understand the technology. And this is the situation where young professionals and more experienced professionals that are at the end of their work lifetime, where we try to bring them together, because the situation right now is the technology is sometimes too difficult for young professionals to understand, because of course they come with an university education, they come with some skills, some knowledge, but 3-4 years of a bachelor's program is not sufficient because the technology is too complicated. On the other hand, we have a high level of experience. We have experts that are older, that are at the end of their working lifespan, and they're quitting their job soon. So how can we bring them together? This is sometimes an issue. We, the consortium, have worked out a learning management system, which is connected with artificial intelligence. And this model is called Wisdom of Age, where we try to bring them together. In order to, of course, it's not finished yet. In order to work on this platform, we conducted a survey to find out what is important for older professionals, what is important for companies to meet the needs, to create a healthy environment for seniors, first of all, because healthy aging in a job, like if you focus on Europe, if you look at Germany, you're supposed to work until 67, and probably this age will rise a little bit, maybe towards 70, because the retirement system is overloaded, and people are still feeling fit, they want to work. So we will have more older professionals in companies, and the juniors that finished university, and maybe they are 21, 22 sometimes. It is not so easy to bring them together and to have it in a social way that both sides are happy. We're thinking about a platform that I will introduce to you. So what is the context of the research? So the European Union created an AAL program, which is part of Horizon 2020. And out of that, Wisdom of Age evolved. So based, what is the base? There is a publication of the European Union which underlines that 99% of the companies in the European Union are small and medium sized. So 99% is really a high number. But unfortunately, 92% of them fail after the first years. And this is mainly due to lack of experience, poor product development, and wrong marketing decisions. So how could we overcome that? Like, mainly young people start their startup, young professionals, and they have a lack of experience, of course. They don't have the older, more experienced engineers, for example, that can advise them. And this is one of the big issues. So even though some companies try to overcome this issue with special trainings, they are failing to do the correct trainings. Why? Because first of all, trainings are really expensive for small and medium-sized companies. It is really hard to come up for the costs. Just to give you an example, a day of an SAP training in Germany costs around about 1,800 euros. For a big company like Daimler, it's probably easy to pay, they do it, but for small and medium-sized companies, it's really hard to bear the costs. So there starts the challenge. So you cannot train everybody, you have to be selective, and therefore you can't have an overall good training that a young professional deserves, maybe in a complicated technological environment. Okay, so what is the philosophy of the research? We were focusing on an e-learning platform to realize that because right now at this moment, most of the e-learning platforms are focused for young children, young students. So, but the focus on the other hand, like for older people that have a lot of knowledge, is not there at the moment. We didn't find that. The mentors, like in a classic small company where the founders are still in the company, young people come into the company and they learn a lot from the mentors. The situation is not there for startups, for example. Therefore, we need a platform where mentors from specific areas get together with young professionals, the knowledge of course. So according to the idea of human-computer interaction, optimization and robotic applications, this paper is focusing on collaboration and learning. Work like human-computer interaction is considered in 2 stages. First stage is human-computer interaction, and the second stage will be the extension where the computer-human interaction happens. So first the human teaches the computer, and later the computer the human. Briefly to the consortium that got together. So this is a consortium of a few partners, as mentioned. Some of them are universities, some of them are companies from Europe. We have partners from Belgium, Romania, Switzerland, where we got together and worked on those topics to improve the situation for young professionals, for seniors that should have a respected environment where they can have a happy aging working environment, and of course for companies, because they benefit from it if their young professionals have a good start. Okay, the human-computer interaction. So what is the WOA project consisting of? It consists of 3 stages. So first of all, the first level is dedicated to happy aging. As mentioned in the European Union, maybe you've seen it in the media. I've mentioned Germany. Also, they are raising the age when people are allowed to retire. As I've seen from the media in Turkey, they are also raising it a little bit. People will work longer, and it should be in a respectful environment, so they can be happily aging in the company, and the company can profit from them, of course. The second level is dedicated to companies that may offer production or service activities that are more sustainable for young professionals. So, for example, startups in the IT sector, and as mentioned, with cobots in new technology. The third level is to activate a digital platform that brings the first 2 levels together: the experience of the old professional and the young professional that wants to learn, that wants to gain experience. So this is possible and foreseeable because the WOA project is developing an artificial intelligence matching platform that brings both together. So the thing is, first of all, ask the right questions to the elders, and then the artificial intelligence brings the correct information to the young professionals that need certain information to perform better. The other focus is, of course, the company. You have to find out what your customer wants and needs. So our digital platform is dedicated for companies that not only fill a demand for better and sustainable production or service activity that is more sustainable. It is also useful for companies in general. It is a social tool for happy aging. So if you have happier employees around, it doesn't matter in which age, if they are more motivated, you will have a better outcome. So we have conducted a survey among European companies to point out the most important issues for the companies. Briefly, the outcome of the survey was 33% of the companies were looking forward to reduce the costs for implementing such an application, reduce the costs for training. As mentioned, for small and medium-sized companies, training can be really expensive compared to their overall revenue. 27% of the respondents were concerned about having a direct access to the right person. So it is not easy. If you have a young professional, you might have implemented a cobot. Let's stick with the example of the cobot, but you have no professional, no older professional that can teach the young professional because you never had a cobot. So how do you get in touch with those persons? It's not so easy when they're retired to get in touch with them. And 22% were considered to accumulate the experience. So I'll go in depth in the next on the next slides. Now the next focus was on the mentors. So what is important for a older employee? Older is not so old. To underline that, we were focusing on 55 plus. So when I talk about old, it's in my opinion up like in the university environment, we have professors that are 74, 76, and they are still really fit and experienced, and they love their job. So this is not considered old if they are active. But we had to name it, so we said older, and it's 55 plus. So for the majority of the mentors, let's call them mentors, was important to stay active when reaching a certain age, to feel respected, to feel part of the society, not being like out of the system. So stay connected, stay in the system. 80%, for 80% it was important. And to realize the potential of the knowledge and the experience in the future, to pass it forward, 74% mentioned is valuable for them. What was interesting, only 41% of the participants mentioned income was a motivation. So we, of course, we asked, is it important to get a salary when being a mentor? And only 41% mentioned, yes, I would like to get something for my activities. But on the other hand, around about 60% would do it, maybe not for free, but it wasn't that important. What was also interesting is most of the participants, which suits to our case, cobots, were from the area of engineering and IT. So these are also one of the most complicated areas. Of course, there are other areas like in the medical field and also in management field can be complicated, of course. But the technology is advancing so fast in engineering and IT that in those areas we see it the most important, and most of the participants fortunately came from this area. Also, the category of skills were mainly engineering, and you see research and development was also among the participants, but engineering was again on the top. Looking at it from a business perspective, from business owner's perspective, the success of such a platform will depend mainly on the competitive situation of artificial intelligence. So all of us have seen the developments which happened really fast with ChatGPT and other tools, Google and Microsoft is fighting to catch up, and probably, I don't know if they will, but I would guess they will somehow catch up. And we will have different types and tools for artificial intelligence implementations. Everything more or less depends a little bit on that, because the artificial intelligence will bring together the mentors and the young professionals. So what is also important is only when the right questions are asked, meaningful answers will be generated, which means on both sides. So the artificial intelligence will first interview the mentors and then give the right information after interviewing or after working together with the young professional, giving him the right input. And this is also, like you see again.
Sorry, your time is up. Please hurry up.
Okay, thank you for the notification. Okay, and the top management should be aware how valuable such training is, because young professionals can perform better if they are trained properly. Okay, this is my conclusion then already. I will go briefly over it. So it is important to create an affordable platform that can connect seniors, mentors, and young professionals. The acceptance of the interface is important. So you have to catch up with people. Interesting facts: the average of our participants were 65 years old. Most of them were from the engineering and IT field and management field. Which skills were important and can be shared: engineering skills and soft skills. Short acknowledgement: the Romanian government supported this research. It founded it. It was a co-founding, of course, and we would like to thank them for that. Yeah, because of the time shortage, I say thank you for your attention. I am open, or we are open for questions. My mentor Adrian Pisla is also in the room. So go ahead if you have questions, please.
Thanks for your presentation. Dear Pasim, do you have any question about this study? Okay, no questions. Thank you again, dear Süleyman Torasan. I wish you success in your career.
Thank you.
Dear Sadeldin Rashid Ahmed. Dear Sadeldin Rashid Ahmed. Okay. Dear Anudeep Dikonda. Dear Anudeep Dikonda.
Yeah, can you hear me?
Okay. If you are ready, you can start your presentation.
Sure. Let me just share my screen. I think I cannot share my screen while the other presenter is sharing it, so.
Okay. You can share your screen.
Yeah, sure.
You have 10 minutes, please.
Sure. You can see my screen, right?
Yes.
Okay. Thank you. I'll just start the slideshow. Okay. Everyone, good evening. I'm Anudeep, and I'm a fourth-year undergraduate student from BVRIT, India. So for the conference, I'm going to be presenting about my major project thesis, which is the design and implementation of motion imitation robot. So these are the contents where initially I'll give you the introduction and our project objectives, and then I'll explain about a methodology and the components used, and which will be carried on by the implementation of a project and results and future scope. We see with the advancement of technology, robots are slowly integrating into our lives. We have various applications that exist, from domestic assistance, education, residential care, to even warfare applications. And all these applications require control strategies and controllers. So to combat this, recently developed depth sensors that we use to resolve the issue of input response and latency is fused with immediate response time. Our model, which we present as a robotic system, which can imitate human motions and work accordingly. So in capturing the human motions, we use a Raspberry Pi camera, where compared to other motion sensor cameras, the Pi camera makes the system easier to communicate with. Our system also extracts the robot skeleton data, which is then processed to produce the robot's joint angles. So yeah, the proposed design of our robot imitates the human motions in real time with a little or no lag. So these are the project objectives where we wanted to develop a human robot, where human gestures are received by the robot and mirrored actions are obtained. And also we want to design it in such a way that it performs with little or no lag. And we also wanted to generate experimental results that could substantiate our project. So coming to methodology, as you can see, we use a Raspberry Pi camera to recognize the various body gestures, and we create a visual interface for human-robot interaction. As you can see in the diagram on the right side, we use the key points, such as for the right hand, we have 6, 8, and 10, where the shoulder, elbow, and wrist are obtained. And for the left hand, it's 5, 7, and 9, respectively. These key points are used as reference during the image processing. And based on the distance between the key points, Raspberry Pi 4 gives commands to the Arduino for controlling the servo motors. We also use an OpenCV framework, which is used for image detection. And of components used, we used a Raspberry Pi camera. We used a skeleton robot where servo motor is connected to it and it performs actions. The servo motor that we used is an MG995 with an operating voltage of 4.8 volts. And Raspberry Pi 4 is the main heart of the project, where all the modules and operating system was installed and actions were performed. And Arduino Uno was used to control the servo motors that we use for the skeleton robot. And yeah, coming to the implementation, we have the block diagram, flowchart, and also the schematic diagram. And at the end, we also have a video presentation which would demonstrate our results. Coming to the block diagram, as you can see, the Raspberry Pi 4 is connected, like the Pi camera and the power supply is connected to the Raspberry Pi 4, and it is also connected to the Arduino Uno, wherein the Arduino Uno is then connected to the 9 servo motors of the skeleton robot. For the flowchart, you can see like initially we check whether the Pi controller is turned on, and then we run the code for post detection. If it is done successfully, the Pi camera will detect human motion. And once that is done, the code for servo motor control is also taking place. And after that, the Arduino sends signals to servo motors for the skeleton robot, and we check if mirrored actions are obtained. If mirrored actions are not obtained, we go back to the first step and we check for any errors that have occurred. If no errors occurred and if mirrored actions are obtained, motion imitation takes place. So this is the schematic diagram. As you can see, the Raspberry Pi 4, like the various pins of the Raspberry Pi 4 and the Arduino Uno are connected to the servo motors. And these are the results. On the right side, we see the person, and on the left side, we see the robot doing motion or mirror actions. We also have a video demonstration, which will further through a project. Okay, yeah. So I just felt like I did not give enough information about my schematic diagram, so I'll just run it over again. So in the schematic diagram, we show the connections of the Raspberry Pi 4 along with Arduino Uno, where it is connected to the 9 servo motors, right? The pin 14 of the Raspberry Pi 4 is connected to the GPIO, which is then connected to the TX1 of the Arduino Uno. The pins 2, 3, 4, 5, 6, and 9, or 10, 11, 12 of the Arduino microcontroller connected to the MG995 servo motors. And the Pi camera module is also connected to the slot in the Raspberry Pi 4 board. And each of the 9 servo motors are responsible for providing the 9 degrees of freedom of the robot. Okay, so at the end, we developed a robotic system where human motions were received by the robot and mirrored actions were taking place. But coming to this project, we mainly focused on human upper body motions. And for the future scope, we would like to develop a fully robotic system, which would even cover the lower body as well. We use the Raspberry Pi OS to obtain the skeletal image of the human performing motions and compared the mirrored actions performed by the robot, which check its accuracy and feasibility of the outcome. We use the Arduino IDE to provide controls for the servo motors of the skeleton robot. Our main aim for this project was to perform real-time human motions on a skeleton robot using the Pi camera. And we believe we achieved the objective. The model we created can be used for various applications ranging from healthcare, rehabilitation, workplace safety, to name a few, where our model that we performed was just a prototype. It could be also used for a factory-ready model as well. For the future scope, we would like the system to incorporate other motion sensors like the Microsoft Kinect sensor, which can also be used to achieve this task, where the Kinect sensor can also reduce the latency and improve performance. Our project can also further look into more human motions, as we have only implemented the upper body of the human, which is imitated. The lower body also can be considered, but it is hard to implement with the camera module that we have used in this project. So yeah, this was a project, and we used some reference papers as well while we developed our project as well. Yeah, thank you. If you have any questions, do let me know.
Thanks for your presentation. Dear participants, do you have any question about this paper? Okay, no question. Thank you again. I wish you success.
Yeah, thank you.
Dear 11D, are you online? Dear Rüya Zaki Kamal Baba, are you online? Dear Muhammad El Unzai, are you online? Dear Saadeldin Rashid Ahmed, are you online? Dear Ivan Garcia, are you online? Dear Ivan Garcia. Okay. Dear participants, thank you for your attending. I wish all participants continued success. The last session of the day is over. I would like to end this session. You can download your certificate from our web page. Have a good day, good luck. Hope to see you at tomorrow's sessions.
Oh yeah, thank you.